Okay, the next question is from electrostatics. Again, uh, this requires some calculation because this case is of variable charge density. The charge density is not constant. What is question trying to tell you that you have a sphere here. The radius of the sphere is A, and then you have this particular sphere that is B, and the charge density in this region is a function, that is function of the distance from center, that is A by R. There is a charge placed at the center Q, and the requirement under question is the field here in this region should be constant. That is, E should be constant, and for that you have to calculate the value of A. Right? So what do we do in such type of problems? We first take an elemental shell. Okay, so we start with that. Let us take an elemental shell. Where is the color pen? Okay, so I take an elemental shell here. Okay. Right? So the thickness of the shell is dx, and this distance I can take it at x. Okay? So what will be the charge associated with this shell? This will be 4 pi x square, that is the surface area, into dx, that would make it a volume, into the rho term, right? And then because we have to write the field corresponding to this point, let us take the distance from the center to be r. So the field due to that q can be directly written, and field due to this charge at the surface of the shell can also be written. What we have to be careful about that, don't cancel x and r, because if you do that, then the answer will go V1. So if I write electric field E from here in magnitude, then the answer would be K. Okay, the charge here is Q, so this will be Q plus the elemental charge here. You told me that charge is 4 pi x square dx, 4 pi x square dx. Of course, I multiply this by rho, and rho is equal to A by x, right? And because I'm interested in all such shells starting from A going to any distance r, so I will write A by r, because I'm writing the field at r, divided by the total distance from center, that is r square. And the requirement is this E should not have r coming into it. Why? Because r is position from the center and it has to be position independent. It has to be a constant field. So if we integrate this, I think we can start and write it directly now. E is equal to kq by r square. This will become kq by r square. This term will be k into 4 pi a. 1x you can lose with this x square. So x dx will yield x square by 2. And of course, if you put the limits, you get r square by 2 minus a square by 2, right? This is what is the expression corresponding to this. Now straight away this k can be substituted. E would be equal to q divided by 4 pi epsilon naught r square plus this 4 pi I can lose with 4 pi, so I get a by epsilon naught. This is 2 and r square here, and there is a term r square that has come here that also should be appearing here, r square. So there will be an r square that I can lose with this. So this term becomes a constant. The only problem is now this term minus 2 you can lose with 4 pi. Okay, k I have already substituted. So 4 pi is already gone as a matter of fact. So what I am left with is a by r square. I have a 2 from here, and there is an epsilon naught term that is remaining after the k and 4 pi terms cancel, and there is a term from here that is a square. Right? I hope I'm getting it right. This term is a constant term, so you don't have to worry about it. The only term we need to worry about is this one and this one. And because you want this to be constant, this term should reduce to 0. So q by 4 pi epsilon naught r square minus that, take it that side for the 0. So a square by 2 r square epsilon naught should be equal, so that they cancel out in totality. So epsilon naught I can lose with epsilon naught, and then r square and 2 can be lost. So what do we get? A would be equal to 2. This would be equal to q divided by 2, and do we have the pi remaining here? Yeah, there is a pi term, and then there is a square term. So q 2 pi a square, that is your option number 4. So the correct answer will be 4 will be the correct answer for this question. Right? Okay, let us switch to the next problem. What it says that 79th question, it's talking about a prism, right? It's talking about a prism. And then he has given you the I. So I is given in the problem as 35 degree. Angle of emergence is given as 79 degree. Okay, let me write the data. I is 35 degree, angle of emergence E is your 79 degree. And one more thing he has given, that is your angle of standard deviation, that is delta, is given to you as 40 degree, right? So straight away we know that del is equal to I plus E minus A. So if I put the values here, 40 is equal to I is 35 plus E is 79 minus A. So if we solve this, 40 minus 35 will be 4, and if you bring the 75 here, 79 here, A will be equal to 74 degree. So we know that this angle is 74 degree. This doesn't look to be 74, but you have to take the numerical value for it. Now, when we talk about grazing emergence, try to recall what was the concept. The concept was, if the light has to come along here on this surface, after that what happens is the TIR takes place and the light doesn't, that is condition of no emergence. And if you recall what was the condition was mu should not be greater than cosec A by 2. You know A here, so cosec A by 2 will be 37. You know the sine 37 is 0.6. So if you try to calculate it from there, you can get the answer going, that is cosec A by 2. Cosec A by 2, that is cosec 37, that is 1 by 0.6. 1 by 0.6 is 10 by 6, that is equal to 1.6 something, 1.66 I believe. Right. So this will be the condition for the maximum mu. It cannot be greater than this value. But then if I try to look at the minimum deviation condition and I take this angle which they have given, which is not minimum deviation, but if I assume that this is minimum deviation and I try to do my calculations from mu equal to sine A plus delta m by 2 divided by sine A by 2 by this formula, then the mu turns out to be 1.4, right? But this angle is not the angle of minimum deviation. So it has to be more than that. It has to be more than that, but it has to be less than 1.66. Okay. So the corresponding value for this will be 1.5. For 1.5, this condition would be satisfied, because you see 1.66, it is making it 90 degree, provided angle of emergence becomes 90 degree, this becomes the case of your critical angle. Okay. Next question says, a student measures time period of 100 oscillations simple pendulum 4 times. The data set is 90, 91, 95 and 92. So 91, 92, 95 and 90. 90, okay, look at it, 92, it is 1 more than this is 2 more than this is 3 less than this. Straight away I know the answer is 92 seconds. You try to find out the mean plus this and divide by 4, 92 seconds. But that doesn't take me anywhere, because 92 is appearing in all the answers, so that is not helping me anyway. Let us find the errors. Error in this will be -1, -2, +5, +3, and one error would be, this will be 0, -1, 0, +3, and this will be 2. Okay. So if we try to find the corresponding error in this measurement, that comes out to be 3 + 2 + 1, because what is the way to find out delta A? Delta A summation with magnitude, because there is no negative kind of error. So negative error, positive error, when you're writing plus minus, you have to be taking everything positive. So delta A divided by the number of measurements that is n. So this will be 6 by 4, that is 1.5. But in the question they have mentioned that the resolution of the watch is 1 second. The resolution of watch is 1 second. Then when the result is reproduced, you cannot measure this 0.5 second. So you have to take the most appropriate answer, that is 92 plus minus 2 seconds, right? Because the error is 1.5 second as it appears, and the resolution of the watch is 1 second. So you have to take 92 plus minus 2 second. You cannot be measuring anything lesser than the least count that you know. 1, 2, 3 is all that I can measure. So I have to accept the error to be 2 seconds. The next question again is a factual question, very, very, very simple. I do not know why 4 questions for semiconductor were required to be asked, but then we know the curves, characteristic curves. I just do them there. Diode, what is the curve? This is the curve for a diode. You know, for Zener diode, what is the curve? The Zener diode curve comes out to be something like this same. Solar cell, something like this. And then you have a light dependent resistor that you can see for yourself. The correct answer there is 4. Look at the graphs. I think everybody should have got it right, because this is something you can't miss. Okay. The next question is radiation of wavelength.